The array method is a strategy that we can employ in order to multiply numbers. In order for us to use the array method, it's important for us to understand what an array actually is. How can we solve 35 times 28 using the array method? Arrays are representations of different items organized into rows and columns. In 3rd and 4th grade, you would have used arrays to help you build understanding of factors. Factors are numbers that we multiply together in order to find a product. For example, when looking at this array of cookies, we notice that there are 6 cookies across the top row and 4 cookies displayed down. Knowing these two factors, 6 and 4, we can quickly multiply 6 times 4 to figure out that there are actually 24 cookies on this tray. Arrays are also relevant in real life in terms of seating arrangements. For example, in this image, we have a picture of an auditorium. In order for auditoriums or theaters to sell tickets, it's essential for them to know how many people can fit into each section of the theater. Arrays can be useful in this situation as well. When we're looking to multiply numbers like 35 times 28, it's first important to know how we would break apart each number by place value. Looking at the number 35, we can easily see that 35 is made up of 30 and 5. There are 3 tens and 5 ones in this number. We can apply the same process to the number 28. 20 plus 8. There are 2 tens and 8 ones in this number. By breaking apart each number by place value, we're able to easily organize these numbers onto an array. Take a look at this image for a minute. What do you notice about how this array is broken up? Are the pieces the same size, or are they different? In order for us to use the array method and show our understanding clearly, we need to recognize that the number 30 is larger than the number 5. Right away, I should know that this box here is going to have a smaller product or answer than the box to its left. So right away, we want to put a big, giant slash over this representation. We need to show when we're creating our arrays the size of our products within each section. When walking you through the process, I'm going to leave the lines out of our box for the moment just so that we can figure out our products and then think about the size that each array box should actually be. The first step in solving the array would be for us to multiply 30 times 20. 30 times 20 equals 600. We are then also going to multiply 30 times 8. 30 times 8 will give you 240. Looking at these two products, right away we can see that 600 is a larger number than 240. Therefore, the size of the array section should be larger for 600 than it is for 240, given the size of our product. Now that we've multiplied both 20 and 8 by 30, we're going to repeat the same process but using the number 5. 5 times 20 gives us 100. 5 times 8 gives us 40. Again, we can see that 100 is a larger product than 40. So when placing our lines into our array, it's important for us to organize our columns and rows to represent the size of each number. 100 and 40 are both smaller than the products to the left. 600 and 100 are both larger than the products below them. It makes sense for 40 to be in our smallest section of the array, and for 600 to be in our largest section of the array. We want to make sure that we're organizing our numbers in a way that makes them visually understandable. Now that we have found all 4 products, we need to take the answers to each of our problems and multiply them together. You can simply string these numbers across and add 600 plus 240 plus 100 plus 40 and receive a product of 980. Sometimes it's beneficial for us to organize our numbers vertically, which would mean that we're lining them up and down by place value to help us organize them in a way that's easier for us to see our answer, which again will be 980. Sometimes it's also helpful when we have many products inside of an array to break them up and add them in pieces. For example, I might start by adding 600 plus 240 and find that the answer, the sum, is 840. From there, I can add my next 2 sections of the array, 100 plus 40, and receive a sum of 140. Now that I have both all four of my numbers added together separately, I can put those together. 840 plus 140 is going to give me the same final answer of 980.